Namaskar, welcome to Exercise Explained. In this video, we would be doing exercise 5B Upthrust in Fluids, Archimedes Principle and Floatation, ICSE 9 Physics, question number 9 and question number 10. The previous questions have been done in the previous videos, the link for which will be provided in the description below. Do check them out, and if you like the video, do share it with your friends and consider subscribing to the channel. Starting with the ninth question. A body of mass, so mass is given as 70 kg, when completely immersed in water, displaces 20,000 centimeter cube of water. Now we should understand one thing here, that if we immerse anything in water, the amount of water displaced should be equal to the volume. So here we can write V is equal to 20,000 centimeter cube. So when we convert centimeter cube to meter cube, we multiply by 10 to the power of minus 6. So 20,000 can be written as 2 into 10 to the power of 4 into 10 to the power of minus 6 meter cube. So plus 4 minus 6 would basically give us minus 2. So we get it as 2 into 10 to the power of minus 2 meter cube. So that's our volume. Mass is given as 70 kg. So I would write M is equal to 70 kg. Since it is given water, density of water, we should remember it as 1000 kg per meter cube. Now we would be finding the weight of the body in air. So for finding the weight of the body in air, I would write WA is equal to M into G. So M is 70 into acceleration due to gravity, we consider it as 10. So we get this as 700 newtons. So this is our weight in air. Now we would be using the formula for upthrust to find the upthrust. So upthrust will be equal to V into rho into G. So we can write upthrust is equal to V happens to be 2 into 10 to the power of minus 2 into rho happens to be 10 to the power of plus 3, that is 1000 density of water, into acceleration due to gravity. So acceleration due to gravity is 10. 10 can be written as 10 to the power of plus 1. So 10 to the power of 3 plus 10 to the into 10 to the power of 1 will be 10 to the power of 4, and 4 minus 2 will give us 2. So we get this as 2 into 10 to the power of 2 newtons, which is nothing but 200 newtons. So we have got the value of upthrust here. Now we need to find the weight of the body in water. So for finding weight of the body in water, we will be using another formula for upthrust, that happens to be upthrust is equal to weight in air minus weight in water. So weight in water will be equal to weight in air minus upthrust. So weight in air, we got it as 700 newtons, minus upthrust, we got it as 200 newtons. So we can write it as 500 newtons. So we have got weight in water as 500 newtons. Now when we convert Newton to kgf, we divide it by 10. So we get, this is nothing but 50 kgf. Now converting to kgf is not 100% mandatory, but the textbook answer is given in kgf, and this is the reason I converted it to kgf. So for finding relative density, we would be using the formula of relative density, that happens to be weight in air divided by weight in air minus weight in water. So weight in air is 700 divided by 700 minus 500. So we get this as 700 divided by 200, 0 cancels. So 7 by 2 is nothing but 3.5. Remember, relative density does not have any unit, so please don't write any unit here. So we have got both the things, the relative density of material of the body, we got it here, and the weight of the body in water, we got it here. So getting into the 10th question, a solid weighs 120 gf in air. So weight in air is given as 120 gf and 105 gf when it is completely immersed in water. So weight in water is given as 105 gf. Calculate the relative density of the solid. Now I would write the given data, that is weight in air is equal to 120 gram force. When we convert gram force to Newton, we divide by 100. So here I would divide it by 100, 120 divided by 100. So 120 divided by 100 gives me 1.2 newtons, and weight in water is 105 gf, so 105 gram force. So again we convert it to newtons, 105 divided by 100, so that gives us 1.05 newtons. So this is weight in water. So now for finding the relative density, we have a very simple formula which we used in the last problem also. Relative density is equal to weight in air divided by weight in air minus weight in water. So weight in air, we got it as 1.2 divided by weight in air minus weight in water. So that is, so we get this as 1.2 divided by 1.2 minus 1.05 is 0.15. So we multiply numerator and denominator by 100. So we get this as 120 divided by 15. So 120 divided by 15 would give us 8. So we got this as 8, and since again it is relative density, there will be no unit. So hope you guys like the video. Do share it with your friends and consider subscribing to the channel. Question number 11 onwards will be there in the next video, the link for which will be there in the description. So see you guys in the next video. Dhanyavad.